So when we do the square root of a negative number, you know that that's going to be I on the outside. And the square root of 16 is simply 4. So you have I times 4. So your answer is 4I for number 1. Let's move on to number 2. Number 2, this is a square root. And remember, when you're multiplying inside the root, you could split the root to each of the terms. So if you did split it to 121, split it to a to the 4th, split it to d to the 6th, you could actually do the square root of 121, that's 11. The square root of a to the 4th, that's really a squared. And the square root of d to the 6th is really d to the 3rd. Once again, the square root is really the power of 1/2, which is why you end up dividing 4 by 2. Because power to a power, you multiply the power of 4 to the power of 1/2. 4 times half, that's like saying 4 divided by 2. That's why we get squared right here. 6 divided by 2, we get 3. And we're dividing by 2 because it's a square root. If it were a third root, you'd be dividing by 3. Let's move on to number 2. Anyways, this is your answer, 11a squared d to the 3rd. Number 3. Right here, we're going to split the root. And you're going to have square root of 45, the square root of t, the square root of u to the 5th. Now, the square root of 45, since we're doing square roots, you want a perfect square number. 45 is not a perfect square number, but you could rewrite it with multiplication to get a 9 times 5. 9 is a perfect square number. So when you split it, you'll actually get 3 square root of 5. Now let's simplify the rest. Now the square root of t, you can't do anything with that. Let me just bring it down, square root of t. And now the u to the 5th right there, remember the square root is really the power of 1/2. So you want this to be divisible by 2. Now 5 so far doesn't work out that great when you divide it by 2. So it would be better if you rewrote this as a 4. So check this out. I'm going to take that u to the 5th and I'm going to rewrite it as u to the 4th times u. That way I could actually split the root to the u to the 4th and split the root to the u. So what we really end up with, when I go the square root of u to the 4th, that's like dividing the exponent by 2. I end up with a nice, beautiful u squared. You with me? And then, of course, you bring down the square root of u. So here's our answer. All we have to do is arrange it. The nice terms out in the front, like the 3 and the u squared out in the front. And all of these other, I can't do the square root of 5. I can't do the square root of t. I can't do the square root of u. So I'm just going to put them all together underneath one square root since I can't do anything right there. 5tu. So there's my final answer for number 3. 3u squared, square root of 5tu. Once again, the square root, you are able to split that square root. So I'm going to split it to the 75, split it to the p to the 7th. Of course, you guys might need some extra space because this paper is kind of small. You might need some extra space. The square root of 75, I want a perfect square number, and 75 is not a perfect square number, but 25 is, right? So 25 times 3, that's how I want to break it up. And I split it. Now, same concept over here, guys. P to the 7th, since it's a square root, you want it to be divisible by 2, and it's not. So you want to rewrite it with multiplication to get something divisible by 2, kind of like p to the 6th, right? So on the other one, I'm going to split it to p to the 6th times p. Does that make sense? Okay, so I'm actually going to do what I can. The square root of 25. What's the square root of 25? 5. That's just 5. Could I do the square root of 3? No, I can't, so let me bring that down. And how about the square root of p to the 6th? That's p to the 3rd power. And now that's a nice p to the 3rd power. Let me just not write a radical anymore on it. And the square root of p, I can't do it. I'm just going to bring it down. So there's my answer. I just need to rewrite this in order. So I want to write the nice terms out in front, like the 5 and the p to the 3rd. There it is, 5p to the 3rd. And then this radical, square root of 3, I can't do anything with that. And that radical, the square root of p, I can't do anything with that. So I want to put both of them underneath the same square root, 3p. And ladies and gentlemen, this is it. This is our answer for number 4. Split up the root on number 5. Now remember, on square roots, it's really the power of 1/2. So when we look at these guys, you want them to be divisible by 2. This is great. Right here, you're going to end up with the x to the 4th. Right? So this is just x to the 4th. This right here is just what? Y to the 3rd. Because remember, the square root's the power of 1/2, so 6 divided by 2 is 3. Now over here, it doesn't work out that great, so it does require a little bit of work where I rewrite z to the 9th as something divisible by 2. I want to rewrite it as z to the 8th times z. And then I'll split the root. That way I could actually do the square root of z to the 8th. What's the square root of z to the 8th? Z to the 4th. Perfect. Okay, and then this square root of z, I can't do anything with it. I'm just going to bring it down, the square root of z. And I still need to simplify the square root of 108. Now remember, the square root of a number, you want that number to be a perfect square number. You want it to be 9, you want it to be 16, you want it to be 25 or 36 or 49, all those perfect square numbers. You want to rewrite it with multiplication to get one of those perfect square numbers. But don't just go with the first one, 9, because 9 times 12 could still be broken down further. Unless you're going for factoring the factor tree, then yeah, go for it. 9 times 12 is working for the factor tree. But right here, I want to use the highest perfect square number possible, which is 36. Okay, so if I go 36 times 3, that'll actually give me 108. So when I split the square root of 36 is really the nice number 6, and the square root of 3 just comes down. So here's my answer. I just need to organize it. What do I mean by organize it? The nice number 6 goes first. The nice x to the 4th comes next. The next nice y to the 3rd comes down, and the z to the 4th also comes down. And now what do I have left? I can't do the square root of 3, and I can't do the square root of z, so I'm going to put those together underneath one square root. Let me do it in black here. So that's going to be 3z inside of the root. Ladies and gentlemen, this is our answer right here for this question. Number 6, we have the square root of a fraction. Always try to see if you could simplify the fraction. Right here we can't. So what we do now is split the radical, split the square root. So I'm going to have the square root of 20 over the square root of b squared. Now this really becomes two simple problems. The square root of 20 you actually could simplify. Let me show you. The square root of 20 is really 4 times 5. And when you split the root, you're going to have 2 square root of 5. You guys agree with that? Yeah. Okay. So that's the numerator. On the top, I will have 2 square root of 5. Now on the bottom, we have the square root of b squared. What's that? B. That's just b. And guess what? We're done. There's nothing else to do. There is no radical in the denominator that you have to get rid of. It's done. We're done. Number 7, a little bit more entertaining. Again, I can't do anything inside of the radical, so I'm going to split the root. And of course, you guys probably need more space. You might want to rewrite this in your notebook. There's not enough space to show all your work here. I could zoom in a lot, so that's why I'm able to do it on the video. Anyway, what is the square root of 32? We need to treat this like if it were a separate problem. Square root of 32, that's 16 times 2, thank you. And we split the root, which means we get what? 4 square root of 2. So let me rewrite my problem so far. Up on top, I have the square root of q, and on the bottom, I have 4 square root of 2. However, we cannot leave the radical in the denominator, so I need to actually get rid of the square root of 2. And the way to get rid of the square root of 2 would be to multiply both top and bottom by that same square root value, the square root of 2. So up on top, I'm going to have the square root of q times the square root of 2. That's going to be the square root of 2q, just putting them together since you can't do either of them. On the bottom, you're going to have this blue 4 and then times, and what do we have here? We have the square root of 2 times square root of 2, which is really a square root of 4, which takes you back to just 2. So I really have 4 times 2 on the bottom. So our final answer is going to be square root of 2q over 8. Number 8, let's again split the root. When I split the root, actually no, before splitting the root, like this is what I'm going to do, but before splitting the root, it's a good idea to look at the inside and see what you could reduce, what you could simplify, what you could cancel. And we obviously have a's on the top and the bottom. This a up here is going to cancel out with one of these. You're going to have 5 left. And then this b right here is going to cancel out with this b right here, so you're not going to have any b's left. So what's left over? You have a 25 up on top, and on the bottom you have a 16 a to the 5th. So up on top we have the answer 5, because the square root of 25 is 5. Now on the bottom, that's where it gets a little trickier. We're going to rewrite the square root of 16 a to the 5th, and we're going to treat it like a separate problem. And I would split the root to the 16 and also to the a to the 5th. Now the square root of 16 is 4, the nice beautiful number 4, but the square root of a to the 5th, I want it to be divisible by 2 because it's a square root. So I'm going to rewrite a to the 5th as a to the 4th times a to the 1. And then I'm going to split the root right there again. That way I could actually do the square root of a to the 4th, which is what? A to the 2nd, and then you have the square root of a that comes down. Let's not forget about the 4 that's out there in the front. So this is what we have left over in our denominator so far. Whoops, circled it wrong. And that's what we're going to place over here in the denominator. Let me actually rewrite everything right here. We have a 5 up on top, and on the bottom we have a 4a squared square root of a. Now the problem is you cannot leave the square root of a on the bottom, so you're going to have to multiply both top and bottom by that same square root of a value. So up on top we will have 5 square root of a. On the bottom we will have the 4a squared, but we also have a square root of a times square root of a, which is just another a. So it's going to be a to the 3rd on the bottom. So our final answer will be 5 square root of a over 4 a to the 3rd. Fun stuff. Let's move on to the next one. Number 9. That's a cube root. Ladies and gentlemen, let's split up that cube root. Cube root of negative 27. Cube root of x to the 3rd. And what is a cube root of negative 27? What times itself 3 times will actually give you negative 27?
3.
Negative 3, right? Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. So that's a nice, beautiful negative 3. Don't put 3i. That's only for square roots. Right here you could actually get negative answers when you do the cube root of a negative number. And then, how about the cube root of x to the 3rd?
X.
That's just x. Remember, it's kind of like saying this number divided by that number. 3 divided by 3 is just 1, so it's x to the 1 power. So my answer is just x. So my final answer there is negative 3x. Number 10, we're going to split up that 3rd root. So you want a perfectly cubed number. Now 32 is not a cubed number. What is a cubed number? We might want to write them down right here on the side. 2 times 2 times 2, that's 8. That's a perfect cube number. 3 times 3 times 3 is 27. That's a perfect cube number. 4 times 4 is 16. 16 times 4 is 64. That's a cube number. 5 times 5 is 25. Times 5 is 125. That's a perfect cube number. So obviously we don't even need those big numbers, but we do know that 8 is a perfect cube number. 32 is not a perfect cube number. So you want to rewrite this with multiplication to include the 8. So we're going to rewrite it as 8 times 4. And when you split the cube root of 8 is what? 2. And the cube root of 4, you can't do it, so you just bring it down. And over here, we have the cube root of to the fourth. We want something that's divisible by 3. So what I'm going to do is rewrite n to the fourth as n to the third times n. And then I'm going to split that root, that third root again. That way, the third root of n to the third is really what? The nice, beautiful n. And then the third root of n, you're just going to bring it down because you can't do it, the third root of n. So here's our answer. We just need to organize it. So let's put the nice terms out in front. That would be the number 2, the letter n, and then we're going to put the third roots together underneath one single cube root. So I'm going to put 4n right in there. And that is your answer for number 10. Number 11, this negative 3 is just negative 3 times, so I just need to remember to multiply my answer by negative 3. And then I'm going to split up this cube root to each and every term on the inside. So if you're dealing with the cube root, you want to think of perfect cube numbers. And 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 cubed is 125. And so on and so on. So what I recommend for you guys to do, you want to rewrite 256 with multiplication to get one of these numbers. So the easiest way to do that is to get a calculator and simply do 256 divided by 64 and see if that works. And if it doesn't work, you probably want to do 256 divided by 27 and see if that works. It only takes a couple of guess and check. So did anybody do that? 256 divided by 64? So with the calculator, we will discover that 256 divided by 64 is 4. So that means I could rewrite it as 64 times 4. And I could actually split the third root on both of those. And we should know that the third root of 64 is 4, the nice number 4. And the third root of 4, you're just going to leave it like that, the third root of 4. Now let's not forget about this outside multiplication of negative 3 that I'm going to end up multiplying by. That's going to give us a negative 12, but not yet. I'm then going to bring this guy down right next to it. And then the third root of x to the 9th over here, the third root of y to the 9th, I'm sorry, I said x, y to the 9th, that's like saying 9 divided by 3, because remember, the third root's the 1/3 power. So what does this equal? Y to the third, right? It's like saying 9 divided by 3, you get y to the third, a nice variable with a power, no radical. So now we just need to rearrange our answer, put the nice values out in the front, and I might as well do negative 3 times 4, give me a negative 12. And then also the y to the third, and then putting together your radical cube root values. So I'm going to put the cube root of 4x. And that would be your answer right here for number 11. Split this one up. Cube root of 135. Cube root of x to the 7th. Now 135, you want a perfect cube number. So it might be 8. It might be 27. It might be 64. 125. I don't think it's bigger than that. So we just need to take 135 with the calculator and divide it by like 27. Or divide it by 64, divided by 8. With 27? Okay, so 135 divided by 27, you get 5. So that's great. So we're going to be able to rewrite it as 27 times 5. And when you split the third root there and the third root there, you will get your answer 3. And the third root of 5, you can't do it. Now over here, we want this to be divisible by 3, so I'm going to rewrite x to the 7th. I'm going to rewrite it as x to the 6th times x. That way I could split the third root, and I could actually do the third root of x to the 6th, which is what? The nice, beautiful x squared value. And then the third root of x, I'm just going to bring that down, the third root of x. Here's my answer. I just need to rearrange it. I have the nice beautiful 3, nice beautiful x squared, and the third root of 5 and the third root of x, I want to put those together as the third root of 5x. That is my answer. On number 13, you have a negative 3 out in the front. Just remember that you're going to have to multiply your answer by negative 3. And you might as well start splitting up the cube root to each one of these guys. So we end up with, now from here, we have to, the 162, since we're dealing with the cube root, we want a perfect cube number. And if we think about perfect cube numbers, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So obviously 162 is not up here as a perfect cube number, so you want a perfect cube number. So you want to rewrite it with multiplication to get a perfect cube number. So on a calculator, go ahead and do like 162 divided by 27. I already know 64 doesn't work, so it's either 27 or 8. So 162 divided by 27, what is that? 6. So I know I could rewrite it as 27 times 6, correct? And now I'm able to actually split the third root. And the third root of 27, that is 3. And the third root of 6, it stays the third root of 6. You can't actually do that. And now this guy over here, this one's nice. The third root of x to the 12th, if you haven't figured it out or if you forgot, you take that 12 and divide it by 3. Remember, the third root is really the 1/3 power, which means that you want it to be divisible by 3. 12 is divisible by 3, and you'll get x to the what? X to the 4th. No more square root. Let me bring it down. X to the 4th, no more square root. And the y to the 3rd, or not the cube root of y to the 10th, you want this value to be divisible by 3, the exponent. You want it to be divisible by 3. So 10 divided by 3 doesn't work out that great. So I'm going to change this y to the 10th. I'm going to make it a y to the 9th times y. Y to the 9th times y. That way when I split the root, I could actually do the cube, or the cube root of y to the 9th, which is really 9 divided by 3, and you'll get y to the 3rd. No more root. But we still have this cube root of y that I need to slap on there onto my answer. So ladies and gentlemen, this is our answer. I just need to rewrite it. I need to organize it. I want to put the nice numbers out in front, the 3, the x to the 4th, the y to the 3rd, and then I'm going to take this cube root of 6 and this cube root of y. Since I can't do them, I want to put them together as one single cube root of 6y, putting the 6 and the y together. And ladies and gentlemen, that is my answer for number 13 on the practice test. Moving to number 14, this is the 5th root. So when I split it up, you need to be thinking a 5th root. In other words, what number times itself 5 times will give you 32? And if you did go 2 to the 5th power, that would give you 32. 2 times 2 times 2, 5 times is 32. So the 5th root of 32, this right here is the nice number 2. Now remember, the 5th root is really the power of 1/5. In other words, you want this exponent to be divisible by 5, and it is. So what's this answer going to be? What is the 5th root of x to the 20th? X to the 4th. No more radical. Good job. Now this other one, this last one, there's nothing to do there. You can't divide 3 by 5, so you're just going to leave it like that. So you're just going to bring that down onto your answer, the 5th root of y to the 3rd. And ladies and gentlemen, that's it. That's your answer for number 14. 2x to the 4th, 5th root of y to the 3rd. Moving on. Number 15, the last one. It looks pretty ugly, but it is pretty easy. Let's split up that 6th root to each one of them. Now, when we look at that first term, the 6th root of 256, so it would be nice if I could get a perfect number to the 6th power. So if I did 2 to the 6th power, I actually get 64, right? Yeah. Now 64 is, I could do the 6th root of 64, but if I go 64 times 4, it actually gives me 256. So all I need to do now is split that 6th root to each of those, and the 6th root of 64, that's just the number 2, and of course we still have the 6th root of 4. And over here, where we have the 6th root of x to the 18th, it's really a division problem. 18 divided by 6, and what do we get? X to the 3rd, no more radical. And then over here, it's really a division problem. It's really 12 divided by 6, because remember, the sixth root is the 1/6 power. So that really becomes 12 divided by 6, which is y squared. And last but not least, you cannot do that last one, so you're going to leave it. And the only other thing left to do is to rearrange it. You want the nice number 2, the nice letter x to the third, the y to the second, and then you want to put your sixth roots together. So you want to put the sixth root of 4 and z to the fifth all together. And that's your final answer. I am going to stop this video and do the second half of the video on the next video. What? The second half of this practice test on the next video.